Hello friends, here we are going to obtain the expression for wave function of Gaussian wave packet, and also we're going to discuss about the speed of Gaussian wave packet. Okay, so before we start, please subscribe the channel, hit the thumbs up button, also share with your friends and for me to create new contents for you, and please help me to grow my channel. Okay, so if you want to follow me, this is my Insta ID, OJHA LAKHYSJIT. Okay, 123. This is my Insta ID. You can follow me on Insta. So now let's start. So now let us obtain the expression for Gaussian wave packet. Okay, so what do you mean by Gaussian wave packet? Now you see, we know that according to uncertainty principle, del x into del p, that means uncertainty, product of uncertainty in position and momentum is greater than equal to a squared by 2, right? A squared by 2, where del x is uncertainty in position, then del p is uncertainty in momentum. Uncertainty in momentum, right? So for Gaussian wave packet, this product, this uncertainty product must be minimum. This del x, del p, this must be minimum, and its minimum value is nothing but del x del p is equal to a squared by 2, right? So let me take this as the equation number 1, right? So now let us consider two functions. Right? Let us consider two functions, f and psi and phi. Okay, f and phi. Let us consider two functions, f and phi. Okay, so these two are obtained when momentum and position operator position operators operate over the wave function psi, respectively, right? Okay, so let me take a new slide. Okay, that means we have considered. So here you see this is the momentum operator, I h squared minus I h squared del x. So when it operates on psi, it gives function f. We have considered that way. This is equation number suppose 2, and the position operator x operates on psi, then it gives operates on psi, it gives phi. Okay, so let it be equation number 3. So we have considered that way. So now you see the relation between f and phi. Suppose f and phi can be related as f and phi can be related as f is equal to, so let me use black here, f is equal to alpha into phi. Okay, so let it be equation number 4. This is suppose equation number 4. Okay, now you see, so what we can do here, So we can check that alpha is it's real or imaginary. Okay, so we can check that one. Okay, so where alpha is a constant, where alpha is a constant. So now what we are going to do, so from this integral, you see integration f star, which represents complex conjugate of f, right, phi dx is equal to, so here what we're going to do, so integration, so here phi f star, so we have seen that this is f, right, so f star gonna be its complex conjugate, so that can be written in this way. This minus will be positive, right, I h cut then del psi star by del x. Okay, psi star is the complex conjugate of psi. Okay, that's it. And phi is nothing but x psi, so x psi dx. Okay, that's what we're gonna have here. So now here you see, in this case, here you see, as we have taken f is equal to alpha into phi, so f star gonna be equal to alpha star and phi star, right? That's what we can have here. So if we replace this f by alpha star, which represents complex conjugate of alpha, then complex conjugate of phi, right? So let me write it properly. Okay. Dx and one more thing, so here we have alpha, this f is replaced by this value. Okay, so dx is equal to, so I h cut can be taken out of this integral, so here we're gonna have integration del psi star by del x psi dx. So here you see, if you see these two to be normalized, integration of phi and phi star, that should be equal to 1. Okay, so that's why phi to be normalized, integration phi and phi star dx, that must be equal to 1. So that's why here we have got, so here this is constant, so it can be taken out, alpha star, and the integration of this part is 1, so that is equal to I h cut integration del psi star by del x dx. So here you see, this part is purely imaginary. Okay, so that's why this is also imaginary, right? Is purely imaginary. Okay, purely imaginary. Okay, therefore this is also imaginary, and hence if alpha star is imaginary, then alpha is also imaginary, right? Therefore alpha is also imaginary. So if it is imaginary, so we can consider that, suppose this alpha is equal to I h cut by b. Let us consider this is, as we have got alpha is imaginary, so let us consider its value is I h cut by beta. Let me take that way. So now you see, So let's go back to the previous slide. Here you see, if we use these two equations, 2 and 3 in equation number 4, then what we can obtain? So we're gonna replace this f by this value and this phi by this value. Okay, so using 2 and 3 in 4, if we use 2 and 3 in 4, okay, then what we're gonna have, using equation number 2 and equation number 3 in 4, in equation number 4, then here the equation number 4 was f, sorry, not f, yes, f is equal to alpha phi, that was the equation, and in equation number 2 we have got f is equal to minus I h cut del phi by del x, and alpha and phi is nothing but x psi. We have got this, okay, x psi. Now you see, we can replace this alpha by this value. Okay, so now let me take this as equation number, suppose what was the last equation, number 4. So let me take this as equation number 5. So let me use here 5. Okay, so minus I h cut del psi by del x is equal to I h cut beta by beta x psi. So here what we have done, we have using equation number 5, using equation number 5. Now let me adjust a little bit. Okay, so here just wait. Okay, so now you can see what we can do from here. Okay, so first let me cancel those terms which can be cancelled. Okay, so if we do so, these two cancels here, right? And is there anything else? No, nothing. Okay, so now let us separate the variables. So doing so, what we're gonna have here, we're gonna have minus or you can write del psi by psi is equal to x by beta del x, and let me write the minus here. Okay, so that's what we have got. Okay, so now if we integrating, so integration of 1 by psi del psi, that's gonna be natural log, let me write ln of psi. Okay, so here on the other side, integration of x dx, that is nothing but x square by 2. Okay, x square by 2, here we have beta also, and we need a integrating constant. So here it is in the form of log, so let me write the constant is suppose ln n, capital N. This is integrating constant. Okay, so let me consider that way. Now let me divide the screen. Okay, so here what we can do here, let me simplify the last step. Ln psi minus ln capital N is equal to minus x square by 2 beta. So if we apply the properties of log, that log m minus log n is equal to log m by n. Okay, when we say natural log, here base is e, in that case we used to write ln. Okay, so hope you know these things. Okay, so now here ln psi by capital N, using that property, minus x square by 2 beta. Okay, that's what we have got. So we know that log m, if the base is a, here is equal to, if it is equal to 1, then we can write a to the power n is equal to m, right? So similarly, here the base is nothing but e. When we say natural log, so e to the power, we can write e to the power, and this can be written in power minus x square by 2 beta is equal to psi by n. This is according to this definition of log, right? So hope you have understood this. So now you see, from here we can obtain psi, that is psi is equal to n e to the power minus x square by 2 beta. Okay, this is what we have obtained. This is psi. So now let me take this as equation number 6. Now let us obtain the value of n. So let me go to the next slide and let me copy this last equation that we have got now. Psi is equal to this. So here is the last step we have got. Okay, so now you see, and in order to obtain capital N, we need to normalize psi, normalizing psi. So what you can have, integration psi star dx is equal to 1. So here we don't have any term containing I, that's why psi and psi star both gonna be same. So let's put the value of psi here, that is n e to the power minus x square by 2 beta, and psi star gonna be also the same, n into e to the power minus x square by 2 beta, as we are not getting any complex number. Okay, so dx is equal to 1. That's what we're gonna have. So n into n square, that's gonna be taken out of the integral. So this is n, here is also n, so n and n square. So then here we have got e to the power. If you multiply these two, then what you're gonna have, 2 into minus x square by 2 beta. So 2 cancel, so we can write minus x square by beta dx is equal to 1. Okay, so in order to evaluate this integral, let us consider that minus x square by beta. So let us consider just x square by beta is equal to, suppose, y square. If this is the case, then you see, if we differentiate with respect to x, then we're gonna get twice y dy by dx, and on this side here we're gonna get twice x on differentiating with respect to x, twice x by beta. That's what we're gonna have. So if this is the result we have got, and from here what we can do, here you see 2 cancels, so that's why what we have got, y dy and dx can be multiplied to other side, x by beta into dx. So here you see this y can be replaced by, y square is equal to this. So y gonna be equal to that's y gonna be equal to root over x by beta, x square by beta, that means x by root beta, we can say. Okay, so that's why let us replace this y by x by root beta, and if that is the case, this x cancels and beta cancels, root beta cancels beta, and it's gonna be root beta. Okay, so that's why dy becomes, this dy is nothing but dx by root beta, and if we substitute this in this equation, then therefore what we can have, n square integration e to the power, here it's going to be minus y square, and instead of dx dx we're gonna get, so this beta should be multiplied here, right? Just wait, it can be written this way, dx is equal to root beta into y. So if that is the case, this root beta is constant, that can be written outside the integral. So let me write the root beta here and dy. So instead of dx we have written root beta dy, right? So root beta is taken outside the integral. That's it. So hope you have understood this. Is equal to 1. Okay, so here you see, and you see, so I think you have got this result of this integral in mathematical physics. So if you haven't got, just remember that the integration of e to the power minus y square dy, this is equal to root over pi. Just you need to remember this result. Okay, so now you see here what we can write: n square root over beta and root pi is equal to 1. Root pi is equal to 1, so that's why n will be equal to 1 by root beta. Root pi means beta and pi whole to the power half, and as we have removed this square, that's going to be whole to the power 1 by 4. That's what we're going to get. And if you put this value of n, in equation number 6 here, okay, then you're going to get the Gaussian wave packet. Okay, so using 7 in 6, using equation number 7 in equation number 6, then what we're going to get? We're going to get psi is equal to, instead of n, we're going to write here 1 by beta pi. Okay, 1 by beta pi whole to the power 1 by 4, and here e to the power minus x square by 2 beta. Okay, or it can be written in this way. Let me go to the next slide. Psi is equal to 1 by beta pi whole to the power 1 by 4 e to the power minus x square by 2 beta. That's what we're gonna get, right? So this is the Gaussian wave packet. Expression for Gaussian wave packet. So to obtain the value of beta, we're going to take expectation value of x square, okay, which is given by minus integration minus infinity to plus infinity psi star x square psi dx. That's how we used to find expectation value, right? So now you see, let us assume that assuming the wave function psi is centered at x is equal to 0 when time is 0, right? So when t is 0, okay, in that case, you see, we know that the width of this wave packet del x, and because width of the wave packet is given by del x is equal to expectation value of x minus expectation value of x whole square. Okay, expectation value of this term is the width of this wave packet, right? So now you see here, when this wave packet, if we consider that it is centered at x is equal to 0 when t is equal to 0, then this expectation value of x, that's going to be equal to 0, right? So in that case, this del x going to be equal to expectation value of x square, right? Because this is going to be equal to 0. Okay, so that's why what we can write here, sorry, I forgot to give the power half here. Okay, so I forgot to give the power half, so that's why if you take expectation value of x square, then here it must be square of del x. Okay, so that's why we can write this as del x square. So what we can write, minus infinity to plus infinity psi star x square psi dx is equal to del x square. That's what we have got. So hope you understood this. So now you see what we're going to do now in this case. So we're going to put the value of this psi here, and psi and psi star both going to be same in this case, because there is no term that containing I, that complex one. Okay, so that's why integration minus infinity to plus infinity, if you put this value here, psi and psi star both going to be equal to this, because here this result doesn't contain I, so if you take the complex conjugate, so it gonna remain same. Okay, so that's why what we're gonna do here, if you multiply this one with itself, then you're gonna get here x square and x square, then 1 by beta pi, instead of whole to the power 4 1 by 4, you're gonna get 1 by 2, and e to the power minus 2x square by 2 beta, 2 gonna be cancelled, and here you're gonna get minus x square by beta dx. And we can write this this part outside the integral, as this is constant, so we can write this way. Just wait, let me adjust it. So we can write this way, right? So now you see how to evaluate this. So here you see result of this integral will be equal to, let me show you, 1 by beta pi whole to the power half, and this integral will be, if you evaluate this, then you're gonna have 1 by 2 beta to the power 3 by 2 and root over pi. Root over pi means pi to the power half. Okay, pi to the power half. Okay, so don't worry, I'm gonna show you how to evaluate this. Okay, so here just to remember this result for the time being. Okay, so now you see, if you cancel these things, here pi to the power half will be cancelled, and if you divide b to the power 3 by 2 by b to the power half, then sorry, not b, beta. Okay, so then you're gonna get beta, right? Beta 3 to the power 2 divided by beta to the power half, that's gonna give you beta to the power 3 by 2 minus half, that's gonna be beta, right? So here on the right hand side, here we should have del x square. So del x square. So what we're gonna get now, so here we're gonna get half beta is equal to del x square, then so beta will be equal to 2 del x square. That's what we have got. So now you see, let me take this as equation number, suppose 8. Okay, now let us use this value in this equation number 8. Okay, so using this value of beta in equation number 8. Okay, so if we use that value here, then what we're gonna get, let me take a new slide. Okay, so let me copy the equation number 8. Okay, here is the new slide, and this is the equation number 8, and we have got beta is equal to 2 del x whole square. If you put this value here, then what you're gonna have, then you're gonna have this result psi. So here we have considered x t is equal to 0. Okay, we have assumed here this function is centered at x is equal to 0 when t is equal to 0. So you can write this way, and 1 by, if you replace the beta by this value, then what you're gonna get, 2 pi del x square whole to the power 1 by 2, sorry, not 2, 1 by 4, 1 by 4 into e to the power minus x square, then replace this beta as well. Okay, then you're gonna get 4 del x square, 4 del x square. That's what you're gonna have, right? So this is what we have got now. Here you see this del x square at t is equal to t at time t is given by del x square at t is equal to 0 plus h cut square into t square 4m square and del x to the power 4 at t is equal to 0. So how we have obtained this result that del x square at t, so we're going to discuss it in next video, otherwise it's going to be very long. So just we are to just I have shown this result to understand the spread of this Gaussian wave packet, okay, for the time being. So here you see this result can be written, and one more thing. So here you see that the Gaussian wave packet we need, it is already obtained in the equation number 8. Just if you put the value of beta, then you're gonna get this. Sorry, not this one. This one. Okay, this is the expression for wave function of Gaussian wave packet, right? If when you put the value of beta, then you're gonna get this expression. Otherwise you can keep this result here also, okay, sorry, here also in this form as well, equation number 8. This is also the expression for the wave function of Gaussian wave packet, okay. So in order to understand the spread of the Gaussian wave packet, we used to express the function in this form, okay. So here this width of this wave function is given by this expression. So how we have got this expression, we're going to discuss in the next video. This is just for the time being, just remember this result, okay. So if you are asked to explain the about the spread of this wave packet briefly, so suppose 1 or 2 marks is given, then you don't need to show this derivation in this one, okay. So that's why I haven't shown here the derivation of this del x. So just I want to explain, okay. So here you see, and this can be written if you see, so there should be a square, okay. So this should be square, okay. If you take common del x square at t is equal to 0, okay, then this result gonna be 1 plus h cut square t square divided by 4m square. This is not del, this is 4, okay, 4m square. Now it's gonna be del x to the power 4 t at t is equal to 0. That's what we're gonna have, right? And if you consider that capital T is equal to 2m del x square at t is equal to 0 divided by h cut, then you see what we're gonna get. Then this expression gonna take this form, del x at t is equal to 0, and if you remove the square, if you take the square root, sorry, if you remove the square at t, then you're gonna get this root over 1 plus small t by capital T square. That's what we're gonna get. Now let me copy this last result and let me go to a new slide. Here you see, this is the new slide. So here we are going to discuss about the spread of the wave packet. So this is the width of the packet. Width of the packet, at time t, right? This is the width of the packet at time t. Okay, that means, and this indicates that the wave packet spreads with time, right? It spreads with time. Okay, so that means width of this packet varies with time here. So now you see from this expression, if small t is very less than capital T, if small t is very less than capital T, then width of the value will be very less here. Then width doesn't increase very much. Okay, and now you see, if small t is greater than capital T, the width of the packet increases appreciably and the packet brings to its, so you can say that the wave packet, or simply let me write packet, begins to spread appreciably. Okay, so now you see, this is the brief description about the spread of Gaussian wave packet. Now let me, as I have said that I'm gonna explain how to evaluate this integral. Okay, so now let me explain this, how I have evaluated this. So you don't have to show this evaluation in exam, just you can use the result directly if you remember it. Okay, but let me explain this. So now here actually this topic is completed. Now let me show you the integration only. Okay, so here you see, so this is the integral we needed to obtain. Let me suppose this is equal to I. So now you see what we're going to do here. In order to obtain this, first you should have the idea of gamma function. Okay, if you check the playlist of my channel, then you're gonna get a playlist of gamma function. If you want to learn gamma function, then you can go through. Okay, so now you see, let me take y is equal to x square, and if you differentiate with respect to x, then you're gonna get dy by dx is equal to, so twice x, and that's gonna give you dy is equal to 2x into dx, and x from here, x can be written as root over y. So in that case here dy, so if you bring the x here and if you replace the x by root y, then you're gonna get this expression. So you can write the 2 here, dx is equal to this. Okay, so then this integral become minus infinity to plus infinity to plus infinity. Instead of x square, we're gonna get y and e to the power minus y by beta, and instead of dx, we're gonna put this one. So that is what, dy by 2 root over y. That's what we're gonna do. So now you see, so in that case, what we're gonna get here, so 1 by 2 is constant, it's gonna be taken out, minus infinity to plus infinity, and if you cancel this y by root over y, then you're gonna get root y, right? You're gonna get root y. Okay, so that means you can write y to the power half, then e to the power minus y beta dy, right? You can write this way. Now you see, here to evaluate this, you must know one thing, that is what you must know one rule, that is you must know these things. So let me write here. Okay, so integration from 0 to infinity y to the power n minus 1 e to the power minus k into y, k is any constant, okay, is equal to, this is equal to gamma of n, gamma function of n by k to the power n. So you must know these things, okay. So here, if that is the case, here what we're going to do, here you can see this y to the power half can be, it can be written as y to the power 3 by 2 minus 1 in order to get this from n minus 1, okay. So then e to the power y by b, this can be written as, instead of k we're gonna write 1 by beta, this is our k into y dy, and here 0 to infinity, so that's why minus infinity to plus infinity, you can make it 0 to infinity. Here we have to put 2, and there is half, so it is half, so 2 cancels, okay. So hope you have understood this. So that's why this result gonna be equal to, if you compare with this one, gamma 3 by 2 and k, instead of k we're gonna get 1 by beta whole to the power 3 by 2, that's what we're gonna have, okay. So now we know that gamma of n plus 1, gamma of n plus 1 is n into gamma n, so we know that. So if that is the case, then how to evaluate this, gamma of 3 by 2, so 1 minus 3 by 2 is half, so here, so n plus 1 is n into gamma n, means what, we have reduced 1 here, here we have taken n plus 1 minus 1, that means n, okay. So that means we have to take here 3 by 2 minus 1, that is half, and gamma half, right. And gamma half is nothing but, value of gamma half is pi, okay. You must remember this value, root over pi, not only pi, root over pi. So if that is the case, so here 1 by b 3 by whole to the power 3 by 2, that's going to be beta to the power 3 by 2, and value of this becomes half root pi. That's how we have got the value of this integral. So let me show you the page here, you see. So that's how we have got this half beta to the power 3 by 2, pi to the power half means root pi. This result, same result, okay. So this is this one can be written as this one, this one can be written like this, okay. So hope you have understood this. So thank you for watching, see you in the next video.